Hi everyone. Today I'm going to explain about my big data project that we have done for the class. So our group consists of 4 members, including myself, Saurabh, Ashrit, and Chandan. So we did the selection of the dataset, pre-processing, modeling, and interpretation for this dataset called Lending Club. So basically, Lending Club is a company where it provides the online platform for the investors and the borrowers. So borrowers can request for the loans, and based on their credit history and other variables that they provide in the application, they are going to provide the loans, and investors going to invest, and based on the interest rates and the risk they are taking, they're going to get the returns. So this is the data set we have taken from the Kaggle. So it has basically 70 columns and almost 9 lakh rows. So this is our data set. So we have like a few important variables that we have considered using the domain knowledge. So loan status is our Y variable. So we want to predict if the loan is going to get defaulted or not. So we have certain categories in the loan status, including fully charged, um, paid and charged off, current, and late status. So we want to consider only the fully paid and the default loans, because the other things that they have categories for are for the current loans. So those are the active loans, so we can't predict for that because we don't have the Y label. So the other things we have considered for the analysis are based on research uh, using the internet and talking to a few people about the risk analysis and what kinds of variables do they consider in giving out the loans to the customers. So this is our project notebook. So where we have done all the pre-processing modeling and everything. So I'm going to explain uh, in like from step to step. So what we have done. So here we have imported the libraries that are required for the project file. So we created a Spark session and we created a data frame, and then we checked the number of missing columns, and we check the number of null values. There are so many null values in a few columns. There are more than 6 lakh null values in out of 8 lakh 9 lakh data set. So we want to drop them because they don't have much information and they are not useful in the analysis, so we have dropped them. And after that we are only considering the good and bad loans, and we are not taking the current loans and the issued loans. Those come into the active loans. So that's for the future purpose, where we, after building the model and after prediction and everything, after doing all that, we want, that is the holdout out of the sample test set. So this is where we are filtering the our data frame based on the current status and the issued. So we are removing those two statuses, so we can have only good and bad loans. So here is our distribution of the test and the main data set. So we have like 6 lakhs and 2 lakhs. So we are taking a sample. So a sample is kind of small here. It's about 1.3 lakh rows. So it's better to run the code on the sample and then check for the bigger data. So that's what we do in the real world in dealing with the big data. So we want to do for the smaller data set, then scale it to the bigger data set. So this is where the visualization starts. So this visualization is to understand the data. So this will be done by my fellow mates, and I will be dealing with the pre-processing and the modeling later on with the visualizations. Thank you.
Coming to the visualization part, we mainly focused on how the good and bad loans were distributed when it comes to the average loan amount and the count of loans that has been taken across the years. So if we can see here, the loan amount was increased across all the years slightly, like there is a constant increase, but the proportion of the good and bad amount that has been taken has remained constant. Also here, if we can see, the purpose of the loans were different, like the highest being debt consolidation. This is a count highest, but the amount that has been taken highest is for small businesses. So we need to consider both the uh, factors in order to predict the good and bad outcome of the loan. So we need to consider both. And coming to this loan status count of the loans that has been taken, good and bad, so it has increased constantly, very constantly from the 2007 year to 2014 year. Since 2015 year is not completely updated, we cannot count on this, but there is a constant increase, even the same trend has been followed for the good and bad loans. Coming to the term, this has a very good factor here. This played a very good factor. If we can see for the 60 months term, it is tending that people are not paying the loan when it comes to the short term, which is 36 months. So we need to consider the term for good or bad prediction. And coming to the interest rate also, if we can see, the lower the interest rate, the better is people are going to pay the amount. But if it is getting higher, then the people are not paying. So we need to consider that also. And coming to the annual income, if you can see, the number of loans taken is high among the 20k to 80k earning people, and 40 to 60k earning people being the highest number of loan takers. But the good amount, as the amount of the as the salary increased, the number of loans taken was also decreased, and also the bad loans that were taken has been drastically increased. This means that higher the package or higher the annual income, then lower the chances of not paying the loan. So this is the interpretation I have deduced from these particular visualizations.
Hi, I'm Fanichandra Saurabh Reddy. From the graph which shows the details about number of loans taken across all the states in United States, it shows that California stands in top with more number of people taking loans, and then followed by Texas, New York, Florida, etc. This could be because more number of people reside in these states, and also most of the population work for software companies or other factories and firms, and they also tend to have more number of credit cards and debt consolidation rates. As explained by Ashrit, when considered loan purpose, we can see that more number of loans are given for debt consolidation and credit card rates. So when we correlate these two aspects, we can see that there is a similarity such that more number of people who are living in these particular states have more number of credit cards, so they have applied for more number of loans. And when considered the graph of in good or bad loans versus home ownership, we can see that their bad loans percentage is more for rental and own homes when compared to mortgage. This could be because people who are living in the mortgage loans wanted a full ownership of their house, so probably they pay loans on time, interest on time, and because of that particular reason, the good loans are more in this particular case. And when we see the credit year versus interest rate, we can see that people who have longer credit history has less interest rate, whereas when people who have shorter credit history has more interest rates. This could be because people who have longer credit history might have an average credit score of good credit score, whereas people with shorter credit history has an average of poor credit score. So maybe because of this reason, the interest rate for people having credit history varies like this. And when we see that number of loans issued across each month in every year, though we cannot conclude proper interpretation, but we can see that for all the years, the number of loans issued were reduced in February, and then they increased till the end of the year, and then we can see that they reached maximum in November, and then they dropped again in December. So we can see that there is a common trend of having the minimum loans in the month of February and having more number of loans in the month of November. So this is the visualizations that we have done, and Nagarjuna will continue with the pre-processing. Thank you.
Hi again. So now I'm going to explain about the pre-processing, modeling, and finally the interpretation. So this is our count of the samples. So we have like 1,38,000 rows. So and in pre-processing, we have discovered from the dataset that few of the columns are redundant because the values in those columns add up to a single column called total payment. So we are removing the columns that's mentioned in the comment. So we are removing here to remove the redundancy because one variable is explaining the other four variables. And then I'm just checking here for the null values if I have any null values, and I have like few null values for the telling 2 years, earliest credit line, and few other columns. So these are like only few, like less than 200, so I'm going to drop them here. And then here I'm dividing the loan status into good and bad category and the late. So then we are considering only the good and bad. So uh, we want our data set to be pure, and it shouldn't be contaminated by the cases with the late. So after 120 days, if the person still doesn't pay his due, then he'll be transferred to the default status. So we are just not considering that. So those are only 10,000 rows. And here we are checking the distribution between the good and bad loans, and we have like 81% for good and 18% for bad. So it's moderately imbalanced data set, and we are interested in knowing about the minority samples that is bad. So in risk analysis, that is kind of prime thing to do. That's what correlates with the real world. Even the banks and the lending club, they are doing the same. So we want to replicate that as well. We want to know like how our model is good in predicting the bad cases. So I have done a few visualizations to understand more about the data. So I have drawn few graphs relating to the loan status and if it is affecting or not. So here checking the loan grades. So these are the subgrades. So there are two things called grades and subgrades. In subgrades, those are categorized from the grades. So it runs from A1 to A5 and D1 to D5, E1 to E5. So we can see there's a fluctuation here, and we should consider this column because we can see the good percentage is more and bad, yeah, there are less, but we have like fluctuations, so we shouldn't be missing out on this data. So I'm considering this column. And next we are checking for the verification status, so if the loan is verified or not. So if the loan is verified, our hypothesis is it's going to be good, not going to be defaulted. We'll test that in the model. So I'm considering this variable, and this is the third variable I have done the visualization for, that is payment plan. So payment plan is something like a new thing that they have introduced. So if a person goes into the default state, so he'll be contacted by the lending club, and he'll be offered to join the payment plan. So in that way he can get back on track to help the investors earn their interest. So it's kind of a good variable, but for almost all of the rows the status is n, so it doesn't make any difference to the analysis. So I'm just dropping this column. And next, the initial list status. So they have like two variables, and the medians of these variables are quite different. I think this is useful. I'm going to check in the model. And then the last visualization is about the application type. So they have two kinds of application types. One is joint and the other one is individual. So for the joint, they don't have any rows because they have recently introduced this feature. This dataset was taken from 2007 to 2015. So we don't have that data. So I'm just dropping this column because it has only one category. And next, in the pre-processing step, we are deriving a column. So this is where we have done some feature engineering. We have derived a new column from issue date and the earliest credit line. We want to know like how long a person has the credit line. So it can help the investors and the lending club to know how long he's been active on their credit line. And this can help predict our model. So that's our hypothesis. And going down now, we have like few strings in our data set in term and employee length. We want to extract numbers from them. So basically for term we have like 36 months and 60 months. We want to remove those months string, and in employee length we have like greater than or plus or other symbols. So we want to extract only numbers, so that's why we are using regular expressions for that. And after that, based on the visualizations done above and based on the domain knowledge, I have dropped few more columns that I deem these are enough efficient in the analysis. And I have removed few null values that are there in the employee length here, and I've seen few null values in other columns as well. So I'm trying to impute them using k-none imputer, because it's kind of best because it takes from the neighbors and gives the surrounding value, which is very near. So we shouldn't be like way off from the original value. So this is the code where we have done all that. And after imputing the columns, I have created like 3 new columns for the imputed columns. So I'm dropping the original columns and I'm just checking the imputation here. And then I'm just transforming the data frame to pandas to see the correlation matrix. And I'm only concerned about the correlation if it is more than 80%. I'm only concerned about that. So there are like few columns who like they have more than 80% correlation with other variables. So I'm just dropping them here: total payment, installment, and recoveries. And then I'm categorizing the variable loan status into factor variable, into zeros and ones for the modeling. So this is where the model starts here. So for the model, we have divided our data set into 2 data, train and test, with the split of 70 and 30, and we are just checking the percentage of good and bad in the test and train. We want to be sure that it should be the same. So it's kind of same like 17.6 and 17.7. So this is where we are importing the libraries for the modeling, and the assembler generally assembles the input columns. And we did some standard scaling here. For that we have used standard scalar, and then we used a string indexer to index the categorical columns, and assembler for assembling all of them. So we generally built 4 models for this project. One is decision tree, logistic regression, random forest, and GPT classifier. So our thinking here is GPT classifier. It's a good classifier. It takes more time, but it gives the best results. So our hypothesis is it should perform well than the other. It should outperform the other models. So this is where we have mentioned the pipeline. So it goes through all the stages in indexing and then assembling everything. This is where we are fitting the pipeline for the train data. And after that we are transforming the train data, and this is where we are using the models to fit on the train data using the output column and the input column. So the y variable is loan status, and the input variables are in the features. That's a vector. And next we are going to see about the results. So after building these models, we put the results into the variables. So the costliest run was for the GBT gradient boost model. So it took like 30 minutes to run. So this is where the interpretation evaluation starts. So for this project, we considered 3 metrics, and one of them being the confusion metrics. The other is F1, and the other one is accuracy. So here we are showing the confusion matrix, and it is very visible that we have high precision scores for in the almost all the models, but we are interested in recall scores because we want to see like in the bad for the bad loans, how well is it predicting. So for the GBT classifier, the recall score is 0.8, which has outperformed every other classifier, and even it has more accuracy F1 score. That's so that was our hypothesis, that GBT would outperform the every model because it uses the boosting. So here we are checking for the feature importances to help the client. So which features are very important to consider while giving out the loan. So according to the our analysis, we found out that some features that they are affecting the loan status. So some of them are funded amount, so total amount, term, and delinquency, and inquiries. So delinquency and inquiries are the two most important features that almost all the models except the logistic regression, but because it has coefficients. See, other three models have predicted delinquency and inquiries are the most important features, giving them more weights while modeling them. And after that, this is where we can see the accuracy levels, and the highest accuracy is GPT classifier. And for even for the FN score, we got like 94.9. So we are pretty happy with the accuracy and FN score falling into the same line and having like good accuracy and the FN score. So the final interpretation is based on the feature importance and the classification metrics. We can say that our model is predicting like with the best accuracy of 95 and FN score of 94. And our dataset is moderately imbalanced, and we are actually interested in predicting the minority class. And we have checked the recall scores, and recall scores are pretty good. According to this dataset, we got like 0.8, so with the GPT classifier. So these are the suggestions. So we want the lending club to consider these two features because they have high importance according to our model. So they want to see about the delinquency of the customer and the number of inquiries he has done in the last 6 months. These two will really impact the loan status of them. And finally, the challenges we faced in doing this project is it's a lot of pre-processing. So we have like different kinds of data, date, time. So we wanted to see like how can we use the date. We have like 6 to 7 date variables. So we want to see like where can we use this in our model. And there are like different kinds of strings and numerical, and we extracted them using the regular expressions, and we did some feature engineering and feature selection. So like it took like most of time to gain the domain knowledge and research on the internet to drop like mostly 50% of the variables and going the model with the 30 variables. And we also did some scaling to improve the performance of the models because they are taking more time on the 1 lakh data set. So these are the things that we did struggle, and we tried to improve it through the solutions. And this is the ending of the presentation, and thank you for listening.